So here it is given that cosine of a minus b over cosine of a plus b added to the ratio cosine of c plus d over cosine of c minus d equals to 0. Then using this fact, we need to find out the value of the product tangent of a, tangent of b, tangent of c, and tangent of d. So let us begin. So we'll start with the given equation. So here we have cosine of angle a minus b divided by cosine of angle a plus b. So what we'll do? We'll transpose the second term to the right hand side such that we have negative of cosine of angle c plus d divided by cosine of angle c minus d. Now there is a reason why we are writing in this particular fashion, because we are going to employ a method known as the componendo and dividendo. Let's first state that method. So let's say we have the ratio a over b equals to another ratio c over d. Then the method of componendo and dividendo tells us that a plus b divided by a minus b, so this will be exactly equals to c plus d over c minus d. Okay, now in our case, if we have a plus b equals to negative c over d, then we componendo dividendo will tell us that a plus b divided by a minus b. So because of this negative sign, we will get c minus d divided by c plus d. So we're going to use this particular componendo dividendo method. So that means we will now get cosine of angle a minus b plus cosine of angle a plus b. Fine. Divided by, we have cosine of angle a minus b minus cosine of angle a plus b. Then this is going to be equals to c minus d. So that means we have cosine of angle c plus d, the numerator minus the denominator, cosine of c minus d divided by the numerator, cosine of c plus d, added to the denominator, cosine of c minus d. So by using the method of componendo and dividendo, we have rewritten our ratio as given in 1 in the new format. Now, there's an added advantage of writing in this particular format, because what we have here is the sum of two cosines and difference of two cosines on both sides. So we can employ the transformation formula, which is given by, let's say, if we have cosine of alpha added to cosine of beta, then the sum of two cosine function transform as the product of two cosine function. That means we'll have 2 times cosine of alpha plus beta over 2 multiplied to cosine of alpha minus beta over 2. Then if we have the difference of cosine function, cosine alpha minus cosine beta, so this is going to transform as the product of two sine functions. So we have 2 times sine of alpha plus beta over 2 multiplied to sine of angle. We'll have beta minus alpha over 2. So let's use the transformation formula to rewrite each of the expression on both the numerator and the denominator. So cosine of a minus b added to cosine of a plus b. So we will get 2 times cosine of angle. So we have a minus b added to a plus b. So that's going to give us 2a over 2 multiplied to cosine of angle. So we have a minus b minus of a plus b. So that's going to be negative 2b over 2. Fine. Then in the denominator portion, we have difference of cosine function. So we have 2 times sine of angle a minus b added to a plus b. So that's going to be 2a over 2 multiplied to sine of angle. So this time we have a plus b minus of a minus b. So that's going to be positive 2b over 2. Let's go to the right hand side. So here we have the difference of two cosine functions. So we have 2 times sine of c plus d added to c minus d. So that sums up to 2c. So we have 2c divided by 2 multiplied to sine of angle. So here we'll have to do c minus d minus of c plus d. So that's going to give us negative 2d. So we have sine of negative 2d divided by 2. Whole divided by, we have the sum of two cosine functions. So we have 2 times cosine of angle c plus d added to c minus d. So that sums up to 2c. So we have 2c over 2 multiplied to cosine of angle. We have the difference. So that will be c plus d minus of c minus d. So that gives us 2d over 2. Fine. So we will further simplify. So let's factor out 2 from the numerator and the denominator. So we have cosine of angle 2a over 2. So that's going to be cosine of angle A. Then we have cosine of, now here we will have cosine of negative b. But cosine is an even function. So cosine of negative b is simply cosine of angle b. Now that means we will get cosine of b whole divided by sine of angle A multiplied to sine of 2b over 2 will be sine b. That will be equals to sine of angle C multiplied to sine of angle, now we have here is negative d. So sine is an odd function, meaning sine of negative d must be equals to negative sine d. So we'll have this negative, so we'll get sine d whole divided by cosine of angle C times cosine of angle d. Fine. Now what we'll do, we'll try to rewrite each in terms of its tangent form. So here we have cosine A over sine A. So this is cotangent of angle A multiplied to cosine B over sine B. So that's cotangent of angle B equals to minus sine C over cosine C. So that's going to be tangent of angle C multiplied to sine D over cosine D. So that's tangent of angle D. Now we know that the cotangent is the reciprocal of the tangent function. So cotangent of A will be simply 1 over tangent of A multiplied to 1 over tangent of B, because tangent of B is the reciprocal of the cotangent function. We have negative tangent of C times tangent of D. So let's multiply throughout with tangent of A times tangent of B. So we have 1 equals to negative times tangent of A times tangent of B multiplied to tangent of C times tangent of D. So if we multiply both sides with negative 1, then we're going to get a final value of tangent of A times tangent of B times tangent of C times tangent of D. So that's going to be equals to negative 1. So therefore, we have successfully obtained the value of the given trigonometric expression. So tangent of A, tangent of B, tangent of C times tangent of D, that's going to be equals to negative 1, provided we have the condition that cosine of A minus B over cosine of A plus B added to cosine of C plus D over cosine of C minus D equals to 0.